Hey everyone, welcome to Code in Motion. Today we're looking at LeetCode question number 11, container with the most order. We're given an integer array called height of length n, and there are n vertical lines drawn such that the two endpoints at I and height I represent the height of the vertical bar at the index I. Our job is to form a container between two lines in the array and return back the maximum amount of order we can store between any two vertical lines. This example is easier seen with a diagram. So we're given the height input array over here, 1, 8, 6, 2, etc. Each of these numbers represents the height of a vertical bar at that index. So you see at index 1, we have 8, which means at the index 1, we have a bar with height 8. In this example, the maximum order we can store between the two containers is 49. And the endpoints of those containers occur at 8 over here, and also occur at 7 over here. This happens at index 1, and then also the last index over here. All right, so before we start the algorithm, I just want to set out a reminder of how we calculate the area of a rectangle, just in case those of you forgot. The area is equal to the height times the width, right? And so we want to be really clever with how we start iterating through this array. We know we're going to use two pointers because we need to keep track of the two endpoints of the container. The question is, where do I start those two endpoints? And so I'm going to take a little bit of a trick over here. And so I'm going to say, if we want to maximize the area, we could try maximizing the height, or we could try maximizing the width, right? And so in this case, it's pretty hard to try to find the maximum height because we're going to have to scan the array. And once we do find the maximum height, what do we do from there, right? It could be like in middle of the array. How do we find the second highest height? Maybe we use a heap or something, but that's already making the problem a little bit too complex. But can we maximize the width pretty easily? Well, we actually can. We actually can maximize the width by saying, let's start. My area of the start of this algorithm is actually going to be the height times the maximum width. The maximum width is simply the two endpoints of the array. If I start an I pointer at 0 and a j pointer at 8, I now have the maximum width that a rectangle can be. And this is how I'm going to start my problem and start the iteration process. And we'll see how we're going to basically move the I and j pointers in order to conclude with the final answer. So let's start with I and j at the two endpoints of the array. And then let's see if we can actually calculate the area between these two endpoints. So I'm looking at a width of 8, and we're actually bounded by the minimum height between height I and height j. Why are we bounded by the minimum height? Well, if we look at a container, if one side is smaller than the other, the more we keep on pouring water, it's just going to spill out on the other side, right? And so the area we get over here is 8. If we add more water, it's just going to spill over on the other end. And so we're really bounded by that height of 1. If that height was 6 or 10 or 12, we could have probably used even more area with the other side of the container, right? And so that's kind of the logical process that we're going to use right now. So far, we've found an area of 8, so we could update our maximum area. So far, the maximum area we've seen was just initialized to 0, but now we have an area of 8, so let's update that. And then the next question becomes, what do I do? Do I increment I or do I decrement j? In this case, we're always going to change the smaller value of the two because that's our limiting factor in the area. And so let's move the minimum between the two, which in this case was I. Now we're basically going to have the same exact problem on the subarray. So now we're looking between the indices of 1 to 8, and the problem becomes calculate the area between 1 and 8. So let's do the same thing. We're going to find the width, which is 7. We're going to look at the two heights. In this case, the minimum height is 7. And the area becomes 7 times 7, which is 49. Let's update our global max area because 49 is greater than 8. And then, which side do we change? We actually change j in the side because it's the minimum height side. Now we're looking at the other subproblem. We're looking for the area between 1 and 7. In this case, the width is 6. Our minimum height is 3. And so the area becomes 6 times 3, which is 18. In this case, there's no need to update the global max area since 49 is larger than 18. Now we move the j pointer since that was the minimum height. And now we're looking at the area between indices 1 and 6. We have a width of 5, and we also have a height of 8. In this case, the height is I is equal to height j, so we could choose whichever one we want to increment or decrement. That doesn't matter, but the area is 40. We're going to update the global max. It still stays 49. And then we increment I in this case. Now we do the same thing. We're going to calculate the area between 2 and 6. So we look at the width. The width is 4. And then the height is 6. So the area is 24. Once again, 49 is greater than 24, so the max area stays the same. And then we're going to move I again, since that's the minimum height between I and j. Now we're going to find the area between 3 and 6. The width is 3. The minimum height is 2. And so the area is 2 times 3, which is 6. No need to update the global max area. And we increment I. Now we're going to try to find the area between 4 and 6. In this case, the width is 2, and the minimum height is 5. The area is 10, and 10 is smaller than 49, so the max area stays the same. Once again, we're going to increment I since that is the minimum height. Let's calculate the area between 5 and 6. In this case, the width is 1. This is our final rectangle. And the height is 4. And so the area is 4, which is less than my maximum area, 49. And so that remains the same. Now we increment I. And I is equal to j, so there's no more area to look at. We just have a single vertical line. This algorithm runs in O of n times complexity because we only iterate through the array once. We only go through each element once. And it has a space complexity of O of 1 because we're only keeping track of the maximum area variable. We're not saving anything else in any other data structure. All right, let's get started with the coding solution. First, I'd like to start with the variables that we're going to use. So what's the global variable over here? Well, it's actually the max area, right? We're going to initialize our maximum area to 0. This is going to be the result that we return at the end of the algorithm. Next, we need I and j pointers, right? So I'm going to say I is equal to 0, and j is equal to the len, the height, minus 1, which is n minus 1. And it's because we really want to start at the maximum width, like I mentioned in the animation portion of the video. And so right now we're going to say while I is less than j, we're going to start processing. My current width is actually going to be j minus I, right? So we could say cur width is equal to j minus I. And the current height is equal to, well, we said that we're bounded by the minimum height between height I and height j, right? So height I and height j, and we're going to take the minimum of that. Now, the max area is actually going to be the max between the max area that we've calculated so far in the algorithm and between the cur width times the cur height. So this portion over here is the current area. And we're just going to make sure that for the max area, our result, we always take the max between the area that we've seen throughout this iteration and the current area. So that's what this is doing over here. And then we have to either increment I or decrement j. And we said we're always bounded by the minimum of those heights. And so if height I is less than or equal to height j, we're going to say just increment I, else we're going to decrement j. And so anytime we write a for loop, we always want to make sure that we're not prone to an infinite loop or a bug in the code. If we look at this logical check, we're always either going to be incrementing I or decrementing j at every single iteration. And so this is guaranteed to eventually stop, this check. So lastly, we're just going to return the max area, and that should be it. Let's run the code. And there we have it. I hope you learned a lot with this problem. It becomes a little bit easier once you see it visually, and so I really hope that the animations helped you out. Try to understand and picture what's going on, and hopefully the algorithm we just wrote makes sense to you. So thank you so much, and if you want to see more LeetCode style videos, feel free to subscribe, like, and comment down below. Thank you so much.